Indeterminate powers. Several indeterminate forms arise from the limit as x approaches a of f of x to the power of g of x. Now, if we have a limit as x approaches a of f of x is equal to 0 and a limit as x approaches a of g of x is equal to 0, then this is the type where we have 0 to the power of 0. Number 2, if we have a limit as x approaches a of f of x is equal to infinity, and the limit as x approaches a of g of x is equal to 0, then this type is infinity to the power of 0. Number 3, if we have a limit as x approaches a of f of x is equal to 1, and the limit as x approaches a of g of x is equal to plus or minus infinity, then this type is 1 to the power of infinity. Now, each of these three cases can be treated either by taking the natural logarithm. We would let y equal f of x to the power of g of x, then we would take the logarithm of both sides. So we would have the natural log of y, which is equal to the g of x times the natural log of f of x. Or by writing the function as an exponential, we would say f of x to the power of g of x is equal to e to the power of g of x to the natural log of f of x. Now recall that both of these methods were used in differentiating such functions. In either method, we are led to the indeterminate product g of x times the natural log of f of x, which is the type 0 times infinity. So for example 8, what we want to do is we want an indeterminate form of type 1 to infinity. So we want to calculate the limit as x approaches 0 from the right of the function 1 plus the sine of 4x to the power of cotangent x. So what we're going to do in step number 1, we're going to write out the function. So we know that we're going to let y equal 1 plus the sine of 4x to the power of cotangent x. Okay, so what we're going to do is we're going to apply this rule here. We're going to take the natural log of both sides. So the next step is we're going to take the natural log of y, and that's going to equal the natural log of 1 plus the sine of 4x to the power of cotangent x. Okay, and so now what we want to do is now we're going to use the rule for logarithms when we have an exponent. So now in step 3, we're going to have the natural log of y, which is going to equal the cotangent of x times the natural log of 1 plus the sine of 4x. Okay, so we still have the natural log of y, and we know that the cotangent of x is the same thing as 1 over the tangent of x. So now we can rewrite this as the natural log of 1 plus the sine of 4x divided by the tangent of x, because we're rewriting the cotangent of x as 1 over x. Okay, so now that we've done that, we can now take the limit of this function. Okay, so we want to take the limit as x is approaching 0 from the right of the natural log of y, which we know is now the natural log of y is what we found here. So we want to take the limit as x is approaching 0 from the right of the natural log of 1 plus the sine of 4x divided by tangent x. Okay, so this gives us an indeterminate, because this would be 0 over 0. So now we can apply L'Hopital's rule. So we have the limit as x is approaching 0 from the right. Now, what is the derivative of the natural log of 1 plus the sine of 4x? Well, we need to take the derivative of what's inside which is 4 times the sine of 4x, because we're taking a derivative of 4x, which is 4. And then the derivative of sine x is cosine 4x. So we're going to get 4 times the cosine of 4x in the numerator. And then we're going to divide that by 1 plus the sine of 4x. And then we're going to divide that by the derivative of the tangent of x. And the derivative of the tangent of x is going to equal the secant squared x. Okay, so now let's go ahead and apply the limit. Well, in the numerator, we're going to have 4 times the cosine of 4 times 0. Well, the cosine of 0 is going to give us 1. And then we're going to divide that by 1 plus the sine of 0. Well, the sine of 0 is 0. And then we're going to divide that by the secant squared of 0. Secant of 0 is 1, and then we're going to square that. So what we have in the numerator is 4 times 1 over 1, which is 4, over 1 squared, which is 1, and that gives us 4. Okay? So therefore, there is that value of 4. Now, so far, we have computed the limit of the natural log of y. But what we want is the limit of y. So to find this, we use the fact of the following. So again, let me write this out. So far, we've computed the limit of the natural log of y. Okay? And so what we want is we want the limit of y. So to find this limit, then we need to use the fact that y is equal to e to the natural log of y. So in part 6, we have the limit as x is approaching 0 from the right of 1 plus the sine of 4x to the power of cotangent of x. We know that that's equal to y. So therefore, we're going to let the limit now as x is approaching 0 from the right of y. Okay, now we need to rewrite this now as the limit as x is approaching 0 from the right of e to the natural log of y. And so what did we find as the limit of the natural log of y? So what we've done here is that we found this limit here of the natural log of y to be 4. So now we can replace this value, the natural log of y, to be 4. So therefore, we can set this equal to now the limit as x approaches 0 from the right of e to the 4 is going to be e to the 4th power. And therefore, there is our result.